The quiet waters of the Bridgewater Canal here at Worsley give us no idea of what a great engineering achievement it was to build it in the 18th century, or of how it revolutionised Britain as it made the transport of heavy goods 10 times faster and 10 times more efficient than it had ever been before. My search to discover how the work of the builders and engineers of the past have helped to shape Britain has brought me close to home, where the mid-18th century saw the building of the first canals and with it the birth of civil engineering. Canals were like the arteries of the Industrial Revolution. They helped to provide cheaper goods and raw materials. They also cut the travelling time down from London to Birmingham to a speedy 4 or 5 days. And it all started off round here at Worsley, near where I live. In the second half of the 18th century, Britain was bursting with industry and commerce. And a way had to be found to move raw materials to the new factories that were springing up and to get their products to the consumers. The answer came from Francis Egerton, the 3rd Duke of Bridgewater, who had made his fortune from coal. Some say the Duke of Bridgewater was thwarted in love, so he channeled all his energies into a grand plan to build a canal from Worsley to Manchester, to get coal there for all the spinning mills that were being built at the time. And of course he engaged the services of a very clever engineer called James Brindley. Brindley was actually a mining engineer who had the difficult job of digging the Duke's mines and removing the water that flooded them. It was this that gave him the right sort of experience to build Britain's first ever canal. This is Worsley Canal Basin, and 250 years ago, there was an hive of activity around here. Little boats like that one over there came through the remains of this here sluice gate here, and of course out of this tunnel, loaded with coal, and then when they got it in the basin they offloaded it into bigger canal boats and off it went to Manchester. This tunnel is the entrance to a labyrinth of 52 miles of underground canal workings which connected the Duke of Bridgewater's coal workings to the Bridgewater Canal. The thing is, all the yellow ochre in the water all comes out of the coal measures and the iron ore, and that's why all the water's stained orange. Work on the Bridgewater Canal started in 1759, and it was 10.5 miles in length and cost nearly £50,000. It was opened in 1765 and was an immediate success. Not only was Bridgewater able to cut the cost of his coal by half, but the canal itself was soon earning him £75,000 a year. Building a canal like this was a major engineering achievement. There was quite a lot of work that nobody can see. Behind the actual facing stonework, there were quite a lot of brickwork, you know, that were there to give it bulk and weight. At the top, they nearly always had great big coping stones, which give the actual edge of it a nice finish. Of course, in the bottom, to stop the water running out, there'd be maybe 18 inches or 2 foot of puddle in the bottom. And what it amounts to is lining the bottom of the porous ground or the canal with a layer of clay. Mr. Brindley had a lot of trouble convincing the men of power and Parliament that you could actually dig a man-made river. You know, they all thought that, you know, if you dug a trench in the floor, all the water would run out of it. Apparently, he went down to Parliament with a big dollop of clay, stuck it on a table and made a big hole in the middle of it and filled it up with water. And, of course, he won, you know, he got his way. And the Canal Acts were passed and lots of canals were built all over England. Now, as you can see, we're ready for the water. And if we've done it right, it should stay full of water forever. Now then, there it is, full of water. Doesn't seem to be leaking. I think Mr. Brindley would be proud of us. Mixing up enough puddle or clay to make a tea service or a parliamentary demonstration were pretty easy, you know, but when you think they actually had to mix thousands of tons of this, and sort of automation crept in a small way. Used to drive herds of cattle down it after they'd put the clay in out of the wheelbarrows, which of course the roofs and what have you would have a wonderful kneading effect in the clay, and of course do the required mixing for them.
To get the Bridgewater Canal from Worsley to Manchester, Brindley had to find a way of getting it over the River Irwell at Bolton. And here he came up with another ingenious solution to the problems of canal engineering. His Bolton aqueduct, which carried boats 40 feet above the river, was so amazing in its time that it was considered one of the wonders of the world. There's not much of it left now, but I can show you what it would have been like, because there's another one over the Irwell not very far away. This one wasn't actually built by Brindley, but it must have been inspired by his innovations. It's disused now, but because of this, it's easy to see how it was built.
There were one near me at Darceleva, and they actually blew the thing up, and they had a tough time doing it. The thing is, it gave me an insight into how the thing was constructed, and I mean, when we were quite small boys, they call it the wooden bottoms because they were actually lined with timber in the bottom, and you couldn't sink in the mud when you went swimming in it in summer. But when they chiselled it apart to blow the arches up, they came across these unbelievable pieces of timber, great blocks of wood about 2 foot square and about 90 feet long, and all completely encased in clay. You know, and when they uncovered it, it were almost like brand new wood, you know. It's incredible, really, when you think, you know, 17 odds and they were taking canals across the tops of great rivers like this down below. The canal was part of a system that were built in the 18th and early 19th century to transport coal and cotton and timber to Manchester, Bury and Bolton and all the little places in between. It's exceptionally well built for a canal. It's very wide as well. It were actually built for boats of 14-foot 2-inch beam, you know, which is it's almost a ship. You know, you go down the Manchester Ship Canal with one of them. The thing is, it weren't only used for carrying coal. They brought cotton and timber and bricks, even China clay, I've heard tell, all the way from Cornwall. And of course they had a packet boat, they had a few, which sailed at great speed and had the right of way over all of the boats, with a postilion, with a bugle. So it went, get out the way, we're coming. I know this canal very well. All my life I've played around here, and I've even sailed along it in an homemade boat made out of a sawn-in-half bicycle wheel, 3 stolen slate lats and a wagon sheet, and tar out the cobblestones to stop it leaking. And I've ridden my bicycle along the edge of here, and I can't swim, you know, all the way from here to Bury, you know, as fast as you could go. So I have had a long and interesting relationship with this bit of canal, believe me.
Because parts of it have been drained now, it's easy to see how well cut the stonework is.
I'm actually walking on the bed of the canal. You can see the quality of the stonework, you know, even below water level will be maybe somewhere around here. And they didn't lessen in the quality of the workmanship, you know, as they got to the bottom. But the real reason that I'm here is this over here. One terrible day in 1936, the canal busted at this point, and all the coal boats went down the hill into the River Irwell. Terrible catastrophe.
You could see from the twisted metal how various attempts had been made to strengthen the bank, and it worked for nearly 150 years. In the end, the pressure of the water got too much. But what this place shows us is the sheer scale of the engineering work that was involved. One of the most ambitious projects was a canal across the Pennines from Leeds to Liverpool. The route had been surveyed by a young engineer called John Longbottom between 1765 and 1767.
Longbottom's plan had been seen and approved by Brindley, and Brindley got the job of chief engineer on the grand salary of £400 per annum. But by this time, he'd become involved with a further 363 other canal projects of one sort or another. And I think his workload proved too great for him, because 2 years later, he died. So Longbottom got the job. It was a huge undertaking. This was no ordinary canal. The Leeds and Liverpool Canal stretched for 127 miles and climbed over the Pennine Chain, the backbone of England.
Work began in 1770, and at any one time the Leeds and Liverpool Canal Company had between 200 and 500 men employed on the construction.
It was also very dangerous. The records of the Canal Company are dotted with names of men who got injured and were paid compensation. There's two here, for instance. George Clark and Hugh Fraser received £1 guinea each when scaffolding collapsed on them in a tunnel that they were doing, and the company paid the surgeon's bill.
So the whole enterprise was incredibly expensive, and it was only worth doing if it could dramatically cut transport costs. It immediately proved its worth when the first stretch running from Bingley to Skipton was completed.
On Thursday, the 3rd of April in 1773, amongst great celebration, 2 barges arrived here at Skipton, and they were loaded with coal. And this coal sold for half the price that coal sold for previously here at Skipton.
The route from Bingley to Skipton winds through very hilly terrain. Now, naturally, water won't flow uphill, so the canal engineers had to come up with a way of making a long, flat stretch of water go up and downhill. The answer was the lock.
There's more to lock gates than meets the eye, you know. When you first look at them, you think they're just a great pair of waterproof doors. But they're not really doors, they have no hinges, you know, they're almost floating. They're so, even though they're made out of great lumps of wood, they're finely balanced with a great lump of timber that's sticking out over there. At each side where the hinges should be, there are 2 semicircular grooves. And the edge of the lock gate is timber, and it's curved to that shape, you see. And when the pressure of the water fills the lock up, it pushes the 2 radius ends, edges, into the grooves, and of course forms a watertight seal. In the middle, of course, it's handled at the correct handle for also forming, you know, becoming watertight. And they're nearly all made of oak and elm. Elm is a beautiful timber for chucking in water and it lasting forever.
There's nowhere better to see the way they work than the 5-rise locks at Bingley, which lift the Leeds and Liverpool Canal an amazing 60 feet.
These things here, they're called paddles, and in the bottom of the lock gate, there are 2 sluice gates, one on each side. It raises up the gate and lets the water out of the lock into the next chamber. Later on, they tried making them out of iron, I suppose, an economy sort of thing, but it didn't work because iron sort of under great pressure bends, and once you've bent it, it don't want to come back. The wood, which of course is a bit more expensive, to dead certain it'll work. They've got to be so tough and strong because of the bashing about they get by boats that were coming to and fro in every day.
A system of staircase or riser locks like this is basically a number of locks which are all joined together. As well as allowing the canal to climb a short, steep hill, they're also cheaper to build than the same number of single locks because they have shared gates. With the completion of this first section of the canal, landowners along the route soon began to see the money-making opportunities it brought them. At Skipton, Lord Thanet, who owned limestone quarries close to the castle where he lived, decided to construct a branch from the canal to the quarries. With a link to the canal, he would be able to transport his stone quickly and cheaply to the businessmen of West Yorkshire. This was the Springs branch. It joins the canal here and runs for about a quarter of a mile up through Skipton to the castle. It stops at the bottom of the cliff, right under the castle wall. And it's beautifully peaceful here now, but 200 years ago it was absolute bedlam.
The limestone will be loaded into wagons and sent down the tramway all the way down to the castle. This is the spot where the wagons finally pulled up on the journey from the quarry. The stones were tipped down chutes in between these abutments and went 100 feet down and landed directly into the boats. The only problem was the drop was so high it actually damaged the boats down at the bottom in the canal. The noise, of course, of the falling stones annoyed the occupants of the castle.
This was a non-stop operation. The bargemen would load up down below, carry their load down to Bingley or Leeds, then come straight back again. And they wouldn't sleep until their barge was waiting in the queue at Springs Branch for the next load. Work went on here night and day. Nowadays, you can only dream of what the racket must have been like.
In the end, the inhabitants of the castle had had enough of the rackets of the stones falling down from these great chutes, so they decided to build a bypass in the form of this magnificent inclined plane. And of course, what happens on an inclined plane, the full wagons would go down on the end of a wire rope, controlled by a brake drum at the top, and the remains of the building that it was once in still there. And that in turn would pull the other empty wagons back up to the top to be refilled and sent back down one more time. And of course, here and there, you can still see traces of the track. The remains of one of the railway sleepers, complete with peg or holding down nail. Incredible. And over here was like the original lighting system. Been here for a long time with looks of things. It's a wonder nobody's nicked that, really, isn't it? In fact, all along this inclined plane, you can find evidence of the railway. It's obviously been a two-track affair at one time. You would unload here at the foot of these old abutments and pour the stone down the chutes into the waiting barges.
The next section from Skipton to Burnley took the canal over the Pennines into Lancashire. To get it over the highest bit, they had to build a tunnel here at Fowlridge.
It took 6 years to build this tunnel under atrocious conditions. The rain constantly came down through the roof, right here, quite dripping down, as you can see. But I suppose before they got the stonework in, it'll be a lot worse than what it is now. Most of these early navvies who did the tunnelling have been ex-miners, and it weren't that important down below, down a pit, keeping everything perfectly straight. And I think this rather accounts to the amount of funny dog legs there are to be found in a lot of canal tunnels where they'd not quite got it in line because the art of surveying them weren't as good as what it is now. First of all, they would go over the top, walking in as straight a line as they could, with, I suppose, the equivalent to a theodolite, maybe a telescope or something as simple as that, and mark out a series of pegs, and then sink a line of shafts down to a level where the tunnel were going to be. And then they would proceed to drive headings from each end of the bottom of the shaft. They would have like a semi-mobile winding gear, a bit like a small colliery would have. The debris will be raised up the shaft in a gibble, which is a name for a small iron barrel. As the tunnel advanced through the mountain, they would dismantle it and move it up the road to the next earth shaft. Robert Whitworth, the engineer, reported to the Canal Committee that the wages were actually 4 times what they should have been, due to the fact that the original estimates were grossly out. They didn't reckon on the shifting sands at each end. When they got here, the lakes and water above were coming in constantly on them and creating trouble. It must have been almost impossible. No wonder it took 6 years.
For some sections of the tunnel, it was so difficult they had to use a different method of tunnel building.
Because the ground was so unstable, they couldn't build a conventional tunnel. So what they got to do is a thing called cut and cover, whereby they dig a great cutting through the hillside and then put in the centering, which this is the centering. In reality, it would be made of wood, but I've used ex-GPO fiberglass telegraph poles. They would then, once the centering was in position, they would then proceed to lay the masonry, which of course had all been cut to shape with the right handle on. With it all being exposed to daylight, they could do a much better job, and actually use much bigger stones. You would have had great difficulty putting them in a conventional tunnel, squeezing them in between the rock roof and the top of the centering would have been very difficult. But when you're up outside here, you could have even had a crane, to lift up the stones and put them on top of the centering. After the last stones had been firmly cemented into position, they would then proceed to cover the whole lot up in very carefully, I should imagine. They wouldn't have really chucked it around, they'd have been making sure that the pressure as they filled it in were sort of equal on both sides to squeeze the arch down onto the centering, which is very important. Lots of disasters have been had when it's not been done quite right. I mean, they must have literally moved thousands of tons of dirt with wheelbarrows, and no doubt up to the necks in mud as well while they were doing it. It's a credit really to our illustrious ancestors. After they'd got the masonry and the centering all buried under 30 feet of unstable ground again, they would then proceed to withdraw the wedges out from underneath the centering, which of course would have the effect of the centering being lowered, and then they could withdraw it. So they could just move it up a bit and put some more masonry on and keep advancing like that until they'd gone all the way through the hillside, as you might say. And as you can see, when the centering's been removed, you end up with rather a beautiful, smooth, stone arch tunnel.
There were no tunnel boring machines, so all the digging had to be done by hand. Sheer hard manual labour.
The men who actually built the canals were professional navvies, and they followed the line of the canal and lived in great encampments, but they were viewed by the locals as bad news, trouble. Here in the Canal Company records is an account of a serious riot which happened at a place called Burrowford. In 1792, it says, a riot of a very serious nature occurred amongst the townspeople of Burrowford and the workmen employed upon the canal. The fighting had to be broken up by the local militia, led by a certain Captain Clayton.
But, in spite of the odd bit of trouble like this, work at the Leeds end progressed at a fair rate. By 1796, the canal stretched all the way from Leeds to Burnley. At the Liverpool end, though, there were all sorts of delays and complications, and it took another 20 years to complete the link all the way across from Leeds. Boats were now able to ply their trade all the way across the Pennines from Leeds to Liverpool, and the cost of raw materials was slashed as the cost of transport came tumbling down. They carried stone and brick to build the factories and the industrial towns that began to spring up along the banks of the canal. Raw cotton and wool direct from the port of Liverpool to the mills of Lancashire and Yorkshire, and the finished products from the mills to the consumers. One of the most magnificent mills was built on the banks of the canal here at Salter by an industrialist called Titus Salt.
Alpaca wool from the backs of South American llamas was shipped all the way to Liverpool and brought all the way across the Pennines here and loaded into the warehouse through these very doors. This is where it all ended up, on top of the factory, where once here there were 1,200 looms weaving 30,000 yards of cloth every day. It must have been quite noisy in here, what with the clatter of the shuttles and what have you. There were 2 vertical shafts come from the engines down below, with big bevel gears on top, which once drove a shaft in this long strip, like a tunnel down the middle of the room, and the belts would come out the floor to each of the looms, howling round all day long. No wonder they were all deaf.
A wool town was built around the mill, and a place like this only existed because of the canal supplying the wool.
In its heyday, over 2,500 people worked in this mill, and they all walked to work. You know, they lived very close in a wonderful model village built by Salt himself. It had everything. It had a beautiful Italian-style church, a library, a social centre. The only thing that wasn't here were public houses, because Mr. Salt was a nonconformist and he didn't approve of alcohol.
For over 150 years it was alive with industry and activity all along the banks of the Leeds-Liverpool Canal. But not anymore.
At the Lancashire end, you were almost lined every 100 yards by a spinning mill. And here in Lee, you know, I remember when I was about 15 years old, coming along this very towpath, and you could see all the great steam engines that turned all these mills round. Alas, it's a lot different now, you know, all the steam engines have gone. It's so sad, really, because these octagonal-shaped towers on each corner have been quite ornate. But when it was first built over, it was beautiful, that. In yellow terracotta and Accrington brick. And it's all very sad now when you come round here and look at all the collapsed buildings and the dereliction.
I actually pulled down a few of the chimneys round here myself, and now this is one of the only ones left, and even this is only half the size it used to be. Everything round here's changed.
The canal's changed as well. It's mainly used today for leisure and pleasure. Canal boat cruising and fishing and generally things like that. Other than the warehouses rearing up in the background, there's precious little left to remind us that this was once the motorway of the early 19th century.
But that's just what it was. Nowadays, it takes a couple of hours to nip down the M62. But before the canal, it took weeks to travel over the Pennines. Those early civil engineers who built the Leeds and Liverpool Canal helped to revolutionise transport in Britain. They made cheap travel across the Pennines possible and laid the foundations for the industrial age. They helped turn Britain into the workshop of the world in the Victorian age. And next week I'll be visiting our greatest and most famous Victorian building, the Houses of Parliament, and I'll be going to the top of Big Ben. If you'd like to find out more about the building of Britain, then why not visit the website at bbc.co.uk/history.